Hi students, today we will discuss about the reactions due to CO bond cleavage. So yesterday we saw the OH bond cleavage reactions, that is acidic nature of alcohols or acidic nature of phenols gives the OH bond cleavage reactions. The now next one is reactions due to CO bond cleavage reactions. Here COH bond cleavage reactions, in this first type if you are taking reaction with HCl or reaction with PCl3, reaction with SOCl2. Here if you are taking a phenol C6H5OH, phenol is reacting with HCl. Here it is a concentrated HCl anhydrous zinc chloride mixture. Concentrated HCl and anhydrous zinc chloride mixture is called as Lucas reagent. Here it is known as Lucas reagent. So when phenols are reacting with the Lucas reagent, what is the product? And similarly, phenol C6H5OH reacting with the PCl3 phosphorus trichloride or phenol reaction with SOCl2. Even in the presence of pyridine or in the absence of pyridine, we can take, and in this reaction if we see, no reaction is observed. Here also no reaction. Here also no reaction. Why they doesn't show reaction with the Lucas reagent or with PCl3 or SOCl2 means here phenol is having a partial double bond nature. Oxygen H, here two lone pairs are present, pi bond, pi bond, pi bond. And in this, if you are taking this lone pair and the pi bond are in conjugation, so this pair of electrons shifts onto this, then this pair about shifts, and so we are getting a resonance structure in which partial double bond is present. OH and positive charge, and here negative charge, pi bond, pi bond. Because of this partial double bond character of a CO bond, the normal reactions will not occur. Means CO bond dissociation doesn't occur very easily. It requires a drastic conditions or vigorous conditions only for the CO bond dissociation reactions. So in normal reagents if you are taking, no reaction is observed. The next one is reaction with PCl5. Here with PCl5, what is the final product or what is the major product of the reaction? They are asking, this is an important reaction. After reacting with PCl5, what is the major product formed? Generally, what we will think is C6H5OH will react with the PCl5, and here phenol is reacting with PCl5. It is normal like alcohols, it will give C6H5Cl plus POCl3 plus HCl. Means chlorobenzene is the major product we think, but actually it is a poor yield. It is not a better yield. It is a poor yield. We are not getting in a large quantity, and what happens actually is C6H5OH phenol is reacting here. Phenol is reacting with POCl3, which is formed here, and three molecules of phenol reacts, and then it forms C6H5O taken thrice PO, or we can write C6H5 taken thrice PO4, triphenyl phosphate. This is called as triphenyl phosphate is formed. Triphenyl phosphate is formed. The triphenyl phosphate is the major product plus 3HCl. That is the major product. So what is the major product in this reaction means triphenyl phosphate, not the chlorobenzene. So please remember in this reaction of phenols with the phosphorus pentachloride, what is the major product means triphenyl phosphate, not chlorobenzene. Okay, it is an important reaction. Next one, reaction with zinc, or it is also called as a distillation process. If we are taking a phenol C6H5OH on distillation with zinc powder, here it is a distillation with zinc powder, then it is undergoing to distillation process to give C6H5 and one hydrogen is added, so we will get C6H6 plus ZNO. Benzene is formed. It is also a preparation method of benzene. And next, ammonia. Reaction with ammonia. Phenol reacts with ammonia in the presence of anhydrous zinc chloride. In the presence of anhydrous zinc chloride at 300 degrees Celsius, the reaction occurs and this is forming C6H5NH2. This is called as aniline or aminobenzene and H2O is formed. So, on reaction with phenol, ammonia gives aniline or aminobenzene. Next one, reactions due to benzene ring. Here these are also called as electrophilic aromatic substitution reactions. So electrophilic aromatic substitution reactions are shown by the phenol. And here on the benzene ring, what is the group present? OH group. Here OH group is having two lone pairs. So it is a plus M effect group and minus I effect group. Plus M is dominating than minus I, and because of its plus M effect group, this is also called as ring activating group. Ring activating group. Why it is ring activating means it donates the electron pair to the benzene ring and increases electron density at ortho and para positions. As we already gave the resonance structures of phenol, please check the resonance structures. So it is called as a ring activating group and electron density is increased at ortho and para position. So it is also called as ortho para directing group. Means if an electrophile is added, when an electrophile is added, that electrophile is always moved or always directed towards ortho position or towards para position. So it is a ring activating group and ortho para directing group. Okay, and in these reactions, first if we are taking the halogenation process. So in the halogenation process, for example, if a phenol is taken, this phenol is reacting with bromine in the presence of CHCl3, chloroform, or in the presence of carbon disulfide, chloroform or carbon disulfide solvents, then it is forming orthobromophenol. It is forming orthobromophenol or parabromophenol, OH and Br. Parabromophenol is formed. In the same reaction we are taking, but if we are taking bromine water, means we are taking aqueous solution. So water and bromine is taken, the reaction is vigorous and we are getting 2, 4, 6 OH and here Br and here Br and here Br. This is called as 2, 4, 6 tribromophenol. Tribromophenol is formed. 246 tribromophenol is formed. So please remember the solvent is important. Here the solvent is chloroform or carbon disulfide. but here the solvent is water. When we are taking the water solvent and bromine mixture, then we are getting 2,4,6 tribromophenol. The next one is nitration. In the nitration process, when phenol is taken, this phenol is reacting with a dilute nitric acid, HNO3, and then here it is forming orthonitrophenol and paranitrophenol. Orthonitrophenol and paranitrophenol is formed. This ortho and paranitrophenol can be separated by steam distillation process. Separated by steam distillation process. Steam distillation process. Here, this is volatile, that is non-volatile. It forms intramolecular hydrogen bonding. It forms intermolecular hydrogen bonding. So they can be separated by steam distillation process. And same phenol if you are taking, but this phenol with concentrated nitric acid or H2SO4 nitration mixture is taken, then it forms 2,4,6 trinitrophenol. Here it is NO2 and this is NO2 and this is NO2. This is called as commonly picric acid. Picric acid. Okay, 2,4,6 trinitrophenol or picric acid is formed. Along with that, H2O molecules are released. Okay, so this is a nitric acid concentrated if you are taking. This is a nitric acid concentrated. Here it is dilute. When dilute is taken, we will get ortho and paranitro. If concentrated is taken, we will get picric acid or 2,4,6 trinitrophenol. This 2,4,6 trinitrophenol in nowadays, how we can prepare? Nowadays, or the latest method. So how we can prepare this is by treating with sulfuric acid first. Phenol is treated with sulfuric acid, then it is forming phenol disulfonic acid, SO3H and SO3H. This is called as phenol 2,4 disulfonic acid. 2,4 disulfonic acid. Phenol 2,4 disulfonic acid, and this phenol 2,4 disulfonic acid on further reaction with the nitric acid, 3 moles of nitric acid, then it forms the picric acid. Okay, same 2,4,6. So NO2 and this is NO2 and this is NO2. 2,4,6 trinitrophenol is formed. So this is the latest method for the preparation of 2,4,6 trinitrophenol, and this is a nitration process of phenols. Next one, Fiddlecroft Alkylation. Fiddlecroft Alkylation reaction. In the Fiddlecroft Alkylation reaction, here we are taking phenol, and this phenol is reacting with alkyl halide. Suppose CH3Cl. In the presence of anhydrous AlCl3, it forms OH and alkyl group at ortho position or alkyl group at para position, OH and CH3. So this is called as orthocresol and this is called as paracresol. So orthocresol and paracresol mixture is formed. And in the same process, Fiddlecroft acylation process. In the Fiddlecroft acylation process, here phenol is reacting with acyl chloride. Here CH3COCl in the presence of anhydrous AlCl3, to give orthohydroxyacetophenone. This is a CO group will come. What is the electrophile here means CH3 CO plus is the electrophile. Here the electrophile is called alkyl carbocation. So you will get CO and CH3. This is called as orthohydroxy acetophenone and parahydroxyacetophenone. So this is OH and here it is C double bond O CH3. This is called as parahydroxyacetophenone. Parahydroxyacetophenone is formed. So orthohydroxyacetophenone and parahydroxyacetophenone are formed by Fiddlecroft acylation process. So phenols undergoes to alkylation and acylation.